Hello. Today I'll be speaking about the Green Party maps. At first, it looks like a map of the United States Green Party, but really it's a hierarchical object model of the entire organization. My name is Christopher Lozinski. I live in Katowice, Poland, and you can find the slides at forestwiki.com/slides. That's forestwiki.com/slides. So let us begin. What are we going to talk about today? First, we're going to discuss why use a hierarchical model. Then I'll do a demo of the Green Party Maps application. Once you understand the application, we can talk about the details of the hierarchical model. We'll talk about the user's experience, a little bit about the data, and some concluding remarks. So why do you want to use a hierarchical model? Well, the basic principle in human factors is there should be no more than about 7 items in a category. So typically people use org charts, their hierarchies. But it's not just org charts. The largest hierarchical data set I know of are the awesome lists on GitHub. So here we have an image from Awesome Plone. When you organize them as a tree, it's just easy to find what you're looking for. It's easy to understand them. And the other piece that's newer is JSON schema. I'm sure you're all familiar with zope.schema. JSON schema does something very similar, but first of all, it's in JSON, and secondly, it's a tree. And so it's very good for modeling complexity. So on the left-hand side, we have the JSON schema, and then we use that to automatically generate a GUI and validate the data on the client. You can then submit that data to the server, and from that, you can validate on the server, just to make sure there's no funny stuff going on, and then update the database. And in particular for people, we use JSON schema for modeling people, and different individuals will see different branches of the tree. We'll get into this in quite a bit of detail. But first, let's go take a look at the application. Here we have the United States Green Party map, logo in the upper left, a bunch of options. You can watch the introductory video. It's organized as a tree. You can think of it as a file system, but we all know it's on ZODB. You can click into it before we do that. You can see all the contact information. On the map, we show all the United States local parties and green parties. We also have lists of just the national candidates, meaning the congressional candidates. Okay, zoom going on in. Let's zoom into California. So California is still showing all of the November candidates. And here, California also has a map. You can see this very nice search filter for which organizations you want to show, which politicians you want to show. And they have the contact information. They also have lists of politicians and candidates. Let's drill into this map further. We're going to go into Santa Clara, and here we have Jake Tonkel. So, Green Party of Santa Clara. So at the county level, you're only seeing the candidates you can vote for. So you see different things at different levels of the tree. California, we see all the candidates for California. At the county, only the ones you can vote for. They could even endorse independents, and they would show up at this level, but not at the higher levels. Again, you have the contact information for Santa Clara. You can see, you can drill down politicians, parties in Santa Clara. Let's drill into Jake Tonkel. Now, what Jake Tonkel has done for his logo is he's replaced it with this image, and then we have acquisition of logos, so all the pages under this branch of the tree all get his image. Very useful. Again, contact information for him. We can go down, and he has, first of all, he has a virtual meeting, and then he has all this other content here. I'm not gonna, we can expand it a little bit if you want. Lots of content. And all of that is shared content. So basically what we do is we take one branch of the tree, and using traversal and proxy objects, we can show that on every politician. So every politician has rich shared information. Okay, so let's go into his virtual meeting. So here we have another content type, which is a virtual meeting, and he has 2 videos there, which he's planning on showing. And we can click into his YouTube video, which is yet another content type. And we can see it doesn't have much information, not much description. Maybe we want to add some description. So this is a content management system, very much like Plone. We get these WYSIWYG editors. You can paste it, do bold, italic, strike through, save and view it. And there it is. But whoops, this is the production website. We really don't want to have it there. And again, this is ZODB. So what we can do is look at the history and restore it. If you had deleted something, you could also use transactions to recover the deleted, and now it's all gone. Perfect. Okay, so let's see where we are on the tree. We're 7 levels deep. Here we have the Howie Hawkins map server, Green Party US map, Green Party of California, Green Party of Santa Clara, Jake Tonkel, Team Tonkel virtual meetup, and Jake for District 6 video. We're 7 levels deep in the tree, and yet you just have an intuitive understanding, you know where you are. For 7 levels deep, at 7 items in every category, that's like 5 million items. Huge complexity, nobody's lost. The problem is with security that there can be a lot of people entering data here and they can step on each other's toes. So for example, for the Jake Tonkel virtual meetup, Jake Tonkel may be too busy to manage it, and so he can assign somebody else to be the editor, and they inherit security for this whole branch of the tree. Remember, this is done based on pyramids, views on objects, rather than ZOP2's permissions on methods, and so security is a lot simpler here. A lot simpler to use and implement. Okay, so that's Jake Tonkel. That's his meetup. Let's take a look at Jake Tonkel himself. Let's actually go ahead and edit him. So here we have the JSON schema. You can see different branches. Introduction, this is what actually goes on the Jake Tonkel object itself. It has a child, translatable content. This could be English, or you could, if you want to, Spanish version, you can add it. Connect, this is where you find all the social media. You can also choose which social media you want to track. And then there are several other branches of the tree. Remember, people and politicians can be very complex. So they can either be a candidate, or they can be an elected official, or they can be a party officer, or they could have been those in the past. So we also have a branch for history. And so when a candidate loses or wins, the candidate info gets moved to the history. When the elected official is over, that gets moved to the history. Same thing with party officers. This is a very complicated tree of well-defined JSON objects. Okay. Going back up, so view. So here you have Jake Tonkel, Santa Clara County. By the time you get up to California, California has a big problem because they have to manage all of these candidates, and they have to manage all of the local parties. And so what they do is they have a management view. Looks remarkably like a ZMI. So like a file browser, here you can actually see the object class, the class of this object. It allows you to manually sort. I better put them back or Nassim will be upset at me. You can sort the order of things. It's JavaScript enabled, and you can cut, copy, paste, rename, retitle, edit. Very basic CMI. Going back up to level, one more level of the tree, view. So 2 more things. One is people may be interested in seeing what's new, what's changed in the Green Party, either at the national level or at a state level. So there's a news option. And here you can see the 10 most recent items that have been added. And if you're actually, it's very efficiently computed. If you're actually the administrator, you want to see if anybody's made any edits also. So we have another progress view. And this shows you any adds or edits, and you can click in and view them. Also, when people submit things anonymously, you have to approve them, so then you get a red flag. Do we have a red flag? No red flags. Okay. Okay, so that's the application. I'll show you one more. Well, that's the application. Let me now take you back to the presentation. So just remember, we showed you national maps and state maps. They had contact info links, so that's a directory. News sites for any branch in the tree. Recommended voting list for the local counties. It's a content management system. I didn't show you the Discord bot, and I haven't shown you the instant backup websites yet. Get to that in a minute. But now that you understand the application, let's take a look at the details of the hierarchical model. So a lot of these ideas come from Plone. First of all, we traverse to an object, nothing new there. Root /map/map/California. But the problem is, if you rearrange the structure of this tree, maybe you add one local party under county, you have a city, you rearrange things, then you change the URL and the end user can no longer find you with the URL. And so we also have something called canonical URLs. So at the root, slash or root, one level down, map, 2 levels down we have California, and 3 levels down we have just slash Santa Clara. And so there are 2 ways of accessing Santa Clara. You can either access it by traversal, or from the root, you can use canonical URLs to jump straight to, and which makes this into a graph database. And so we tell everyone it's a hierarchical model. Really, it's a graph model. Just primarily, we hide that. There are a number of other reasons why it's a graph model. The other piece we use is pyramids views on objects. So in the upper left-hand corner, we have the map view. Next, we have the edit view. After that, we have the news view. And then we have the supervisory view I showed you a minute ago. We also have a lot of views for manipulating the tree. So on this left column, we have all the ones for manipulating the tree. And on the right one, there's a whole bunch of different content types that we can add that the management, that the operators of the system can add. Okay, now let's take a more detailed look at the hierarchy. So at the root, we have a root object. We didn't really look at that much. 1 level down, we have the Green Party of the United States. 2 levels down, we have all the state parties. And 3 levels down, we have local parties. Actually, you might have like New York City, and then within that, there are additional 3 different parties. Okay, going back up to the Green Party of the United States, that's where we put the president and the vice presidential candidates because everyone in the country can vote for them. At the state level, ideally, we put the governors and senators because everyone in the state can vote for them. And then at the local levels, we're going to have all the other candidates. So here's the basic tree. But remember, there are politicians hanging off different parts of this tree. And then off politicians, we have the JSON schema, and they can have events and videos. So it's a really complex search tree, but this is just the backbone of the tree. And so here, remember, I was just saying about the JSON schema adding on the politicians. Here you can see the connect branch for all the social media and other links to the candidate. A very complex hierarchy, but hierarchy works great. So let's talk about the instant and backup websites. It's a tree. It's really easy to hide all but a small branch of the tree, and then you can create a separate website just for that person. So here we have the branch for Howie Hawkins. Actually, during the US presidential first disastrous election, so embarrassing, the website went down, and it was actually down for 2 days. But so in just a few minutes, it was possible to create a backup website for Howie Hawkins. But to do all of this, I mean, in some sense, it looks really simple, but there's a lot more complexity underneath the hood. So I'll show you just some of the content types. So like any content management system, you have to have pages with WYSIWYG editor, markdown pages, particularly for the data scientists, links, YouTube videos, online events, online organizing, we didn't see those, logos, banners, files, basic content management type stuff. There's also a whole bunch of map types. So there's Google Maps, but I worried about Google tracking everybody. So I went to OpenStreetMaps. I use Mapbox. I suspect they track everybody also. There are also GeoJSON maps. So these are like the states or California used to show the GeoJSON boundaries of a state. Organizations, these would be parties, local parties, caucuses. Politicians can either be candidates, elected officials, party officers. And then map organizations are things like California, the United States, which are both a party, but they're also a map. Okay, so those are the application-specific ones. I'm not going to talk much about the underlying skin and presentation classes. Let's now switch to the users. The data is hand curated. Okay, so here's our data curation team over on Basecamp, some 18 people, I believe, maybe 19 now. Actually, at first I thought that most of the data entry was done by 4 or 5 people. It turns out one guy did 70%. And we did crawl data wherever possible, but even where we crawled data, the data that we crawled had also been hand entered. So it's a very manual curation process, leads to very low noise. And it's very useful. It's a directory. Any node on the tree for an organization or politician has all of their contact information, including events page, link to the events page, maybe a donation page, their social media. And the data is really loved. I asked my boss what he thought about it. He said, I'm ecstatic. I asked Holly Hart, very reserved head of the CCC co-chair, coordinated campaign committee. She said the CCC really likes this. And lots of other people love what we're doing. And people are really upset if it's wrong. So we added a candidate to a particular state, and that state, a party did not like that candidate. And so, oh boy, did we hear from them rather nasty messages. Okay, no problem, we removed the candidate. And that candidate was even more upset that we'd removed her. So people really care about this data. And of course, it's very labor intensive. The big problem with hand curated data is finding volunteers. So the awesome lists managed to find volunteers. We managed to find enough volunteers. Either that, it can generate lots of good jobs for people. The data entry has to be managed. So the project manager made a list of all the states, and as each state was completed, he checked it off. And then when one of the states had an error, we reported it, we unchecked that state, and the appropriate person went and fixed the data. So it has to be managed both at that high level and at a detail level. We have this management view of which items have been changed more recently, just so we can audit and keep an eye on everything. Okay, now let's talk less about the end. We finished speaking about the user experience. Now let's talk about the data. So the data is low noise. First of all, it's hand curated, so that gets rid of a lot of errors. And then the users give feedback. They really care, and if there's a problem, they tell us about it. And then there are a number of things we can do to improve the signal to noise ratio. So here we have both the California and the New York maps. So those states can just link to those maps. And either on the state maps or national maps, we can either show candidates or parties. Actually, we have a lot more filter options now. And so you can get a view of the map that just shows the data that somebody needs. So very low signal, very good signal to noise ratio. And we have this new filter option so that there's a long list of things so you can filter down exactly to what people want to see. It's very low noise. It's also very small. So not counting the images, the whole thing fits on 10.5 megabytes. And so I don't know if you remember the flopticals. Maybe a lot of people never even used one. It'll fit on half of a floptical. That's not counting the images. And so it's really fast. For those who are not from the US, this is Roadrunner, always too fast for Wiley to carry to catcher. And why is it fast? Well, it's so little data, you just cache everything in memory. And on top of that, we have a caching web server so that the anonymous user just gets instantly served web pages. So very fast. And of course, because it's so small, you don't need much of a server. So even during the elections, we only had a 4 gigabyte server, maybe 2 CPUs, 80 gigabytes, $20 a month, either on Linode or on DigitalOcean. If you're going to be efficient, you also want the code to be small. So for not counting the third-party libraries, which all shrink-wrapped, just downloaded from GitHub, there are only 12,000 lines of Python code plus some JavaScript. So massive code reuse leads to very small code. And so then you only need one developer. And remember, there are 6 different applications in here: national and state maps, there's a directory, instant backup websites, news, recommended voting lists. That's a whole content management system and a Discord bot. That was in Ruby, so we're not counting that. Okay, some concluding remarks. Before the map, the Green Party never really knew what the strongest states are. Now, you can look at it. Clearly, there's a big gap in the middle of the country. We call that the red states. I can't help it. Actually, I met one of those red state guys, but that's another story. The state maps are very useful. My boss's boss, he is the co-chair of the Illinois Green Party. And he said until he used the maps, he never really understood the state party. We also did some analysis of the most active state parties. No big news there. Let me spend a little bit of time speaking about the software tools. I have 10 minutes left here. So first of all, we all use a file system. Hierarchical file systems were initially used in Multics in 1965. Actually, I used Multics. And since then, actually, the functionality is reduced since Multics with Linux. But it's so much nicer to store stuff in an object database like the ZODB, because a file system just has files and directories, and files don't have children, and directories, they don't have attributes, they don't have methods, you can't send them a message. So let's take a look at the best example of this, the B-tree images. So in the ZODB, the B-tree images, they have children, which are the thumbnails. So if you go to /social media image, you'll get the map of the entire country. But if you need a thumbnail, you just go to social media image /400Y, /200W, or /100W, and you get the appropriate size thumbnail. And you don't have to store these ahead of time. What the ZODB will do is if they don't exist, it'll generate it for you at runtime. And so that's just great, because I'm not a graphics designer. I never know how wide these things are supposed to be. I just plug in the size I need, and it gives it to me. Perfect. JSON schema is, typically JSON is a single file, but if you actually look at it, let's take a look at it. If you take a look at the JSON schema definition, it is this enormous thing, right? It's because people are complex, and all of this information is needed. All of it's very efficient. All of it generates the user interface. But to edit this file, it was just a nightmare. And so what I did is I broke it up into a JSON folder. So here we have the top level of the JSON tree. It doesn't show any of the attributes. It doesn't show any of the children. Where are the children? Well, it's in a ZODB. They're in the child objects. So here you can see all of those different, each of these basically corresponds to a panel on the user interface. Introduction actually is for the object itself. Content is either the English or the Spanish, the editable content. Contact are all the social media links. Candidate info, you only get it if you're a current candidate. Elected official, only get it if you're an elected official. Party officer, you only get it if you're a party officer. And each of these you can click into and edit too. So each of these are, much more reasonably sized, easy to edit this stuff. So by not using files, but by using a JSON folder, it made the whole JSON schema stuff really easy to do. I'm actually going to start offering classes in JSON schema. Okay, going back to, okay, so that's JSON schema. I have a few more minutes, so let me show you one more thing. The other thing that's really nice is Pug. So HTML is also a tree. And so Pug is the leading templating language in Node.js. And here you have, what you do is you use the indentation to define the structure of your HTML, and then it generates your HTML, and here you can render it. And so there's a very nice Pug editor. And if you have a syntax error, because indentation isn't consistent like in Python, it gives you a flag right away. So back to my final slide. Thank you very much. If you have any questions, please contact me. My name is Christopher Lozinski. You can reach me on Twitter, @PythonLinks. If you want to visit the map, you can go to map.howie2020.tech. And the map was built on top of the Forest Wiki, so you can go to forestwiki.com or forestwiki.com/slides to see the slides. Thank you very much.